Good morning, everybody. Today's session is about physics and chemistry. It's specifically about how to approach the sciences as a Cambridge homeschooler. I've done these sessions on maths and English, and I wasn't really sure whether I should look at chemistry and physics separately, but I decided to do it together, and we'll see how it goes. Thank you for being here. I was going to live stream the session, but it is currently very early in the morning. The sun is still coming up, and I'm just doing it beforehand so that I can be here in the chat. I know that many of you are here because of the recent exam results, and it really has raised questions for many people. So the issue that I've been hearing is that students have worked hard, some of them at school, some with tutors, and some have worked alone, but their results didn't always reflect that effort. And it was less of a problem for maths and more of a problem when it maths and the sciences, and more of a problem when it came to English. But I do think that it is still relevant for English, for the sciences. Either way, what people have been asking me is whether Cambridge is right for them. So I saw a question the other day of IB is actually people are getting really good results for IB and the pass rate is really high. So maybe it is a better option to go for IB, especially if they are wanting to get into the medical field and stuff like that. I mean, there is some merit to that argument. Cambridge has some really, really good perks, but South African universities don't always see those perks. Either way, I focus on Cambridge. The British curriculum. It's not necessarily always Cambridge. I also teach Pearson. But what I want to do today is talk about the fact that Cambridge sciences are not inherently harder. CAPS isn't easier. Cambridge sciences aren't very forgiving. Similar to maths. In systems that are built on exam coaching, like CAPS, okay, I don't want to diss anyone, but in systems that are built on exam coaching, you can learn the pattern of a test. You can succeed if you just have strategic, shallow learning. You don't actually need to know that much. Now, Cambridge, especially if you're looking at AS or A level, it's designed to punish that approach. We don't want that. So it requires structured and deep understanding. Our children's intelligence is not the question. It's not whether they're intelligent enough to do it. But we do need to be questioning how their learning is structured. And today is about how we're going to structure the way that we teach sciences and approach sciences. The non-negotiable first step for me, always, is to start with the end in mind. So the biggest mistake we make is building without knowing the destination. So we need to know where we're going. We can't just, I can only think of an Afrikaans word, yeah. We can't just play around with, oh, these are science concepts. Now, I personally really, really love science museums because I am myself a child. Okay, I'm not really, but I have 5 children and 2 of them are homeschooled, and our science curriculum is very much built around going to Sci Bono and stuff like that. But the reason it works for us is because I know where we're going with it. So I see something, I'm like, oh, this is an introduction to molecular chemistry or organic chemistry, and we talk about it. And so my kids come with questions, and my son's favorite thing at the moment is telling me how, like, wanting to know if we can figure out how many atoms are in a person. And I mean, at some point, I'm going to actually have to figure it out with him because, that's what you have to do. But your map for all of it is the syllabus. So it's not some vague guideline, it is your precise contract. It tells you exactly where to go. So you don't have to have millions of textbooks. You just need that syllabus, and it tells you where to go and how to do it. Okay, it tells you exactly what's going to be assessed. And it's not just about assessment, as I'll talk about later, but knowing what will be assessed tells you kind of where your focus needs to be. Sorry if there's a noise. My dog is currently at the door, and stopping a border collie is impossible. So what I need you to do this week, okay, talking to you like you're my students. Your action for the week. I would recommend that you download the IGCSE and A-level physics and chemistry syllabi. Now, when you look at this, you're not supposed to just skim. You need to be looking for the assessment objectives. So in the assessment objectives, you need to find the balance between the knowledge, the application, and the analysis of content. Then you also need to be looking at the command words that is explored in the syllabus. So we want to look at define, describe, explain, calculate, evaluate. What types of answers are these requiring? And then we build it into our life. Throughout my whole life with my kids, I use these. Okay, define that, describe it. We use this language in our everyday life. So by the time they get to their exams, they know what to do. Okay. Then the last thing we look at is the mark scheme. So where are the marks allocated? So in science, we're looking for process, explanation, and method. Okay. Those are usually what gets you more marks than the final answer. Okay. So because of this, exam coaching is not going to make things very easy, because if we're only going with familiar questions, it creates this illusion of competence. It makes students feel as if they know what they're doing. They get to the exam, they're like, yes, I know what I'm doing. And they finish the exam and they're like, I did so well. And then they get their results and they got like a D. Okay. The thing is, what Cambridge excels at is presenting the concepts in unfamiliar contexts. So it can take that concept and put it in a different context. And if you cannot actually deeply think about how to change those concepts from one area to the other, you're going to struggle. So if a student can't look at the syllabus and roughly predict what the exam will ask, they're not going to be ready. So let me just say that again. A student needs to be able to look at the syllabus and predict what the exam is going to ask. Okay? That's not exam coaching. That is kind of knowing how the concepts can be applied to different contexts. Okay? So the core principle here is that you need to teach backwards from the syllabus. Okay. So, oh, we're ahead of time. Look at that. So, the first thing I want to talk about, okay, let's just not number them because I've mentioned some things already. So, the Trivium is Plato and Socrates. I'm super into them. And they had a really big impact on how education is still approached today, right? So one of the concepts is the Trivium. And I see learning as its own art form. It's a way, there's a good way to do things and like an okay way to do things, I suppose. And then there's just the wrong way to do things. I'm not going to pretend that everyone's right. So your Trivium is Trivium Tri 3. So your Trivium is grammar, logic, and rhetoric. Okay, it's not just for literature. It's a universal pattern of mastering any discipline, especially science. So we can use grammar, logic, and rhetoric to master literally anything. Okay, so if we look at grammar, what we're looking at the symbols like FMA. We're looking at like force, mass, acceleration. We're looking at units like newtons, kilograms, meters per second. We're looking at the equations. F is equal to ma. These are all our grammar. These are our building blocks to understanding. It's how do we communicate what we see in science, okay? And then we look at our terminology like ionization energy. We look at diagrams like circuits and apparatus. Okay. Anyway, but these are your things that I often have parents come to me and say, my child's walls are filled with sticky notes. These are the things that are on the sticky notes. If it ends at the sticky notes, we've got a problem. Okay. Now, at a primary or lower secondary level, we're looking at handling equipment, naming observations accurately, and talking science with correct words. Okay. I use with my 7-year-old the word hypothesis all the time. I look at the scientific method. Love the scientific method. I specifically enjoyed studying the philosophy of science when I studied. Like I'm super into the philosophy of science. Um, but the scientific method is something that we apply every day. It's something that we make part of our lives. And talking about it with the correct words rather than what do you think will happen, I can just say, what's the hypothesis? And you just need to explain to your 7-year-old once what that means, and they will feel like the smartest person in the whole world for knowing that word. And they will start to use it, and they will start to come up with hypotheses in different areas of life. So a warning here is that if we rush abstract notation, and we force kids to write chemical equations before they've mixed substances, or before they've used F is equal to MA, or we force them to use F is equal to MA before they've felt force and motion, it's going to create a very fragile and memorized learning. So we need to start off with curiosity and experimentation. And basically, the notation of the experimentation comes second. We don't first teach them how to explain the results before they've gotten the results. Let them explore, let them learn, let them see what happens if they jump down the jungle gym. Let them figure it out. Okay, let them start low. Okay, so next one I want to talk about is logic. So this is your why, and it's the why behind the science. So we're looking here at cause and effect. We're looking at conservation laws. We're looking at proportional reasoning. If I double this, what happens? Okay. We're looking at relationships between variables. I mean, I explore this in the kitchen. I make bread. I currently have some bread in the kitchen. That is, I need to put in the oven in about an hour. So we're looking at this, and I can ask my kids, so what happens if I double salt? What happens if I double the yeast? How is that going to affect the situation? And I make a fun bread which only requires flour, water, salt, and yeast. And then we look at the different flavors we can get when we add thyme, when we add folds, because the folds affected what would happen if we change the salt percentage. And we also use baker's percentages. In the kitchen, we work with a scale. And so we treat baking as science because it is. So this area of logic is where your experiments become essential. So it isn't just about watching experiments on YouTube. And it isn't about having these perfectly, especially at primary school level, it's not about having these perfectly set up science labs. It's about training logic. And so that's why I enjoy going to Sci-Bono, because it trains logic. It gives them experiments that they can do. They've got a bunch of physics experiments at the top. They've got some chemistry experiments in the sessions that they offer. And it looks at why these things happen, how they happen, and they'll do an experiment and I'll be like, okay, so why did that happen? Let's figure it out. And so this builds the habit of, if I change this one thing, what happens and why? And it also teaches them to only change one thing at a time so that they have some kind of control over what's happening. So without logic, science is just disconnected facts. So this is the stage that exam coaching completely bypasses. So we can't be going from knowing all the facts to missing the stage of experimentation. That's where logic lives. Logic lives in experimentation. Now, from there, we need to be able to communicate our scientific understanding, and that's your rhetoric. Okay, so we're looking at how explaining the mechanism in words. We're looking at, okay, so what is a fire? What's happening when that fire happens? My kids have these little baggies that they put in the fire, and then it makes rainbow fire, and they absolutely love it. And we have a lot of bonfires. My kids love a good bonfire, so we have at least 8 a year. And we make it like a whole thing. And so they love these things. So we looked at, it happened once, and my friend was here, and he's a pharmacist, and we were like, okay, well, how can we make this? How can we make this at home so that we can have it in bulk? So it's about explaining what is actually happening in words. It's about writing a clear method, explaining how this experiment happens, interpreting a graph, interpreting the information, interpreting the results. It's about justifying the conclusion using the evidence. Okay, so where the Cambridge exams are won or lost is that examiners assess your clarity, your structure, and your precision. Okay, so to test whether your child or student actually knows this, whether they own it, if a student cannot explain a concept clearly, then they don't own it. There's this very famous quote of, if you can't explain it to a 5-year-old, you don't understand it yourself. Absolutely, yes. So if a student can't explain it, they probably don't get it. And so they might recognize it, but they can't use it independently. And if we're writing exams, we need to be able to use it independently. Okay. Now, the quadrivium. So I spoke about the trivium, right? So the quadrivium is quad 4, and this is the content of science. So what makes up maths? What makes up science? So let me just give a breakdown first, and then I'll go into the details. The trivium is how we learn, and the quadrivium is what we learn. So it's an ancient framework for mathematical sciences. It maps directly onto physics and chemistry. So arithmetic means number, and it's the foundation. So we're looking at, well, let me just do an overview first. So we've got arithmetic, which is number, and that's a foundation. Then we've got geometry, which is looking at space, and that's the visual mind. Then we've got music, which is pattern, and this is the heart of relationships. We've got astronomy, which is motion, and this is applied abstraction. Okay, so when we look at arithmetic, we're looking at units, conversions, ratios, proportions, significant figures. So if this arithmetic is weak, it's going to be the brick wall in our physics. That's why we need to take maths and physics at the same time, or we require maths to take physics. Because if you don't have a maths basis, you're not going to be able to do the physics. So you can't reason about force if you can't manipulate kilograms and meters per second squared. So next one is geometry. So that's space and how it all fits visually into your mind. So we're looking at force diagrams, vectors, molecular shapes, graphs, circuit diagrams. Science is deeply spatial. Okay, so if a student can't visualize, they're going to struggle to reason. Okay. Next up, we've got music. And this is your pattern. So this is really the heart of relationship. So we're looking here at patterns, ratios, and harmony. So in science, the music, the patterns are algebraic relationships. So we're looking at the trends in the periodic table. We're looking at stoichiometry in chemistry. We're looking at direct and inverse proportion in physics. Okay. So this is the part where science is actually quite algebra heavy. So we need to be pattern spotting in order to do it. And so pattern spotting is like the algebraic basis of what's happening. Okay. And so naturally we need that maths foundation. And I did do a video on maths and how to approach maths. Now, astronomy is about motion and how celestial bodies are moving. So we're looking at applied abstraction. So astronomy represents change, motion, and it represents the systems in context. So if we look at mechanics, energetics, reaction rates, radioactivity, this is all astronomy. It's taking all this information and abstracting it. Okay, so because of all the abstraction and actually making it practical and real, abstract maths is going to meet the real world here. And so our weak foundations are going to be fully exposed at this point. Okay. So I put together a bit of a reality check, and I've also created a survey that you can do. I will have it up soon. It might already be linked at the bottom. But this, let me just, I want to do a stage by stage reality check. How do you know where you're at? Okay. So in the primary years, we're building the garden. Okay, we're building the garden of science. So our focus is on curiosity, sensory experience, rich language. Okay, to do this, we're going to take concrete things, concrete concepts. We're going to then make them pictorial. We're going to then abstract them, okay, by introducing the concepts of algebra and things like that. So we're mixing, we're building, we're observing, we're talking. And when we play, we are researching. Okay. My son loves statistics and he's like, okay, well, what is the probability of this happening? And I mean, it's not always age appropriate. He doesn't really get what he's doing, but he's starting now to understand on a deeper level what statistics is, but we learn this through play. So some common mistakes that people love is filling in worksheets about the water cycle instead of watching a pot boil. What happens when a pot boils? The water goes to the top, it drips down. We can use that as an explanation. Honestly, a lot of teaching happens in the kitchen. So I am the primary teacher in my house. We also have other adults in the house who are teachers. But my friend who lives with us, she creates courses on courses for the minds and health and safety stuff. And so sometimes she'll sit with the kids and she'll be like, okay, so we're working out the volume of this thing. And they'll work with her on how different temperatures create different volumes and how it impacts the pressure and stuff like that. And this is real life stuff. And so we should be watching pots boil instead of doing worksheets on the water cycle. Okay. So then at IGCSE years, this is where we're really sorting. I think I called it that in my maths thing as well, the sorting phase. And this requires algebraic fluency, logical sequencing, and structured working. You see how maths and sciences are going together. So our best practice is short daily practice. We need short daily practice, weekly mixed problem sets. So what is happening? Let's take past papers as mixed problem sets. We can get problem sets everywhere. And the golden habit, the biggest thing for maths and the sciences is explain your thinking to me. If they can start to explain their thinking, they will do well. So if your primary foundations are weak, IGCSE is just going to be this frantic mess and stressful exercise. It's just going to be a stressful exercise and exam training. It's not really going to be true learning. Okay. Now at AS and A level, this is where it's all tested. Okay, this is where we look at whether your house is going to fall apart and your foundations are going to crack. Okay, so here the pace is going to be slower because the depth is going to explode. We're going to go deeper and deeper and deeper. And so it's going to feel like a slog sometimes because we're researching. We're looking deeper into this thing. So our expectations shift to abstract reasoning. We're looking at precise language. We want independent thinking. Okay. So here, your gaps, there's no way to hide your gaps now. Any students who memorize the types of radiation in IGCSE are going to flounder when asked to model decay in the new context of A level. Okay. Because radiation and decay work together. And so we need to understand how the chemistry works in order to actually explain it and actually explore it further in modeling decay or something. So exam coaching is just going to fall apart here. I'm a parent, I get it. Parental doubt is normal. The question is not about whether you've got it, because I mean, we all doubt ourselves. Okay, maybe some people don't, but I do. I really do. Even though I'm so confident with my students, I'm not always so confident in the educational decisions I make for my kids. So I just have to deal with it and go with it. Just because, like, if I made a decision and I'm going in a direction, I need to go with it. I can't constantly every 6 months be changing out what I'm doing. Okay. So there's never going to be this perfect resource. Okay. Constant curriculum hopping and searching for the perfect resource is a reaction to anxiety. It undermines progress. Okay. There is no perfect thing, but commitment beats perfection every time. My broccoli, my border collie. So we need to just choose a framework and, like the one we've discussed today, and stick with it long enough for it to actually work. Instead of overhauling the whole system, if something doesn't work, just make small adjustments and make whatever works for you, make it work, right? So Cambridge is going to reward patience, precision, and intellectual humility. It's not going to reward random little shortcuts. So your job is not to be the expert physicist, but it's really to build the learning environment. We need to build a learning environment that's going to value deep understanding over shallow coverage. And this shift in mindset is the most important lesson of all. So I've created a survey check-in thing for you to actually figure out where you're at. And at the end of it, I've got a link so you can contact me, and you can also just contact me from this video. But you can contact me and I can walk you through we can discuss how you can actually move forward in your physics and chemistry. Yeah, I really do implore you to go and do the survey. I can help you interpret the results if you want. You can just message me. But it is quite self-explanatory and it shows you exactly where you're struggling, where you're stuck. Download and skim the syllabus. Okay, no, download and don't skim the syllabus. Download and actually look through, read through the syllabus and understand it. And then reach out to me. Let's talk. Let's discuss how we can move forward.